Hi everyone, in today's video we will go over our Python code for Word2Vec. This is going to be a very simple code because we will use the package that is already done called Ginseng, and we will use all the functionalities of Word2Vec from this package. You can choose to use something different, but usually we use that one that is already structured and has all the functionalities we need to deal with Word2Vec. So I will go over the documentation with you so we can highlight some parts that are very important, and we will also cover some important features that we have in Word2Vec. So important thing for the import part of this code, we have to import the test utils, the data path, so we can check where our file is, the utils, and the models. Here, this package has different models, and we're gonna use Word2Vec. So in this example, we are using some Reddit dataset that have been already text processed before. So we already did the cleaning part, and we only have the tokens already separated, and that's one important thing. When using Word2Vec, you can go ahead and split your information, your comments into different words, and to generate the vectors, that is the most efficient way. Or you can go ahead and have your sentences without the tokenization, but that will take a little bit more time for the computer to train, like the algorithm. So first, we have to go over all our comments in our dataset, that is our CSV file, where each line is a comment from Reddit. So we create a class called myCorpus, and we're gonna iterate in each line of the CSV file. So here we have the data path. That's my data path. Of course, you have to change. For a line in open, and we're gonna open this file, it will use the utils from the Ginseng in each line. So in that way, we have the comments. It will be all my corpus. So we're gonna go over my corpus using this data path, and we will be able to get all the comments in that way. So to use the model, I usually call model just for simplicity, but you can call the variable whatever you want. Word2Vec, it's not, I would not encourage you to use Word2Vec as the name of the variable, because that's one thing that Python has, and it's very important. If you define a variable with the name of some function or some other variable already built in Python, you're going to change the original variable. So I would not recommend to use Word2Vec, because we know that Word2Vec is a variable inside one package. So I usually use model, but you can use any name that you want for variable, sorry. Okay, so here we'll call the Ginseng.models that we imported here, and we're gonna call Word2Vec. Don't forget, in this case, Word is capitalized and V2Vec as the same. So we have here sentences, size, windows, minimum count, workers. And for this model, Word2Vec, we have 24 different parameters that can be used to change the Word2Vec model. So here I put it a simple summary of what we usually use. The sentences are the list of tokens that the program will iterate over. If not in the program already, you can use the corpus file, path to a corpus file. Why I'm saying like if it's not in the program already? Because you can use like Word2Vec in Ginseng package already have a very good vocabulary And they have different ones, like from Twitter comments or from Wikipedia. So they already have a corpus. If you just want like a very generic or generalized analysis, for example, it's also good when you want to compare between like subreddits, the most similar words, with the information that you have from Wikipedia, for example. Let's say that the most similar word to baseball in the baseball subreddit is best. And let's say that if we use in the Wikipedia information, that will be sports, let's say. So it's good so we can compare both of the outputs from the Wikipedia and with the baseball comments or the Reddit comments. So as we can see here, the difference between this sentence, it will be where you get your comments from. In this case, we are getting our comments from the baseball subreddit from March 2017. The vector size is the dimensionality of the Word2Vectors. You don't need to specify, but it's important to understand the dimensionality that you want to use your vectors. And why I say that? In this case, we decided the size 50. Usually it's a common practice to have the size of the vector as 50. But you can say that you need more dimensionalities to get more information about the vector. And then you put 100. You have to remember every time you increase the size of the vector, it will take a little bit more time to generate. And also, if you decide to have a little bit more less, like the size a little bit smaller, you know that you're going to lose some of the parts of the dimensionality. So usually what they used in the original paper, it's 50. So that's what we are using here. So the window is the maximum distance between the current and the predicted word within a sentence. How many words in the context will be considered to predict the target word? That's an important thing because if you only consider, let's say, the window as 2, you will only get 2 words in each side of the predicted word. But if you get like 10, maybe your comment not even have like 21 words, or even you were just like increasing the information that you have about the word, and it won't be even like necessary, like you will not use all that information, or you were actually introducing some noise to the prediction. So that's the important thing. Again, they used in the original paper 5, and that's why we are using that. Minimum count. It's the count only words with frequency bigger than the number specified, to avoid the very rare words that can be typos or order. Original paper used 5. That's why we are using 5. But really depends on your application. Let's say that we are getting the comments from the whole year. So 5, minimum count of 5, it's very small. Like considering that you have the comments from the whole year, that word should appear at least, I would say, like 2 or 3 times a month. So we would have to increase that. That's important because this is kind of a cleaning of the text as well, and that you don't need to do it before. And that's very good because you don't have to implement any code to take it out the words with a lower frequency. In that way, you can keep them in the corpus in case you need, but you can use the functionality of the Word2Vec to change that. And so for more okay, so the last one is SG. It's the training algorithm. It's set to 0, that it's the continuous bag of words. But if you change to 1, it will be skipgram. Okay, so for more parameters, please check the documentation. So we will go over the documentation, and I will show you how it looks like and what we can get, what kind of information we can get for them. Okay, so here is the Word2Vec embeddings, and they give you like a little introduction, and they quote the two papers that Thomas and its a student and his students published about Word2Vec and how they got that to that stage. They also talked about other embeddings like Doc2Vec and FastText. And here they use some examples of how to use the Word2Vec. This documentation is not as good as the other ones that we saw before, and keep in mind that because they are a little bit confused. But we can use like many different things from Word2Vec. So it's important to go over this so we can definitely check what is going on and to see how to use, like better use the Word2Vec. So we have here, like I told you, the pre-trained models, like they have here the list that they have. See here, like they have Google News, Wikipedia, Twitter, and those are the size of the vectors. So you can choose to use either each size of this one. And then glove, look at this. They did like glove vectors. It's a little bit different. So we're gonna see next time. But they use like the most similar Twitter. So most similar to Twitter is Facebook, tweet, Facebook, Instagram, chat, hashtag, tweet. So that's very nice. Like the most similar to Twitter are those ones. Okay, so here we have exactly, right here, what is the Word2Vec model. So like I said, we have 24 different parameters that we can change. And here we can see some of the ones that we talked. And for example, here we have hierarchical softmax if we want, and the negative sampling if we want. So if we want to change for any, like change, usually they already use like softmax. And if we want to change for hierarchical softmax, we have to use this one, or negative sampling, we have to use this one. So we have here the max of vocabulary size. Let's say that we don't want to use, everything we have. So we just limit ourselves to part of the vocabulary. So, and that's all we have, like all the parameters. I will not go over all of them because we already went through the most important ones, and you can just check here to see if you want anything different and in your model. Also, here they have some of the examples, and like build vocabulary. Those are functions that they have when you are using Word2Vec. So you can just like use those later on to find what you need, like we're gonna use most similar and all that. And also we can save our model and to open them again. And that's very important because we can train in our huge data set. Let's say that we have the comments from 1 year and we train our data set, but we did not finish what we had to do. So we just saved the model, and this model will be saved with those parameters. And then we load back that model and continue our analysis. This will be important after, when we start like using applications, using Word2Vec in applications, using Glove in applications. And that way we will be able to look at the models later on. We can just save them. So yeah, that's a lot that they have here, and you can go over and try like to familiarize yourself like in how to use the Word2Vec. But the most important things are in the parameters here, and we covered a summary here. Okay. Okay, so back to our code we have here. I wanted to print the vector of the baseball. So here we have the 50 dimensions of the vector. And in this case, remember this model, we are using continuous bag of words. So here we want to check if there is any similarity between baseball and sport. And we check here and we have 86% of similarity between baseball and sport. Also, we want to check baseball and apple, and we see that we only have like 15% of similarity. That's very interesting because if you want to see like the similarity between two words in a different context, let's say we are not using Reddit comments, but a TV show script, and we want to see if they are similar or not. That means when we say that they are similar, that means that they occur in the same context. So baseball and sports occur in the same context. However, baseball and apple rarely occur in the same context. So here we have the most similar to baseball. We have football. It's the most similar sport. It's the second most similar. Basketball, hockey, soccer, college experience, cricket, NCAA, and Japanese. And remember, this is from where we trained our vectors. We trained in our data set that is from baseball comments from 2017 in March. So it's very specific. We're not getting a huge data set to train it. So the information that we are getting here can be a little bit biased, you know? So here we have the most similar to positive, sports plus baseball, negative basketball. So we have football, experience, hockey, soccer, event, Japanese, culture, cricket, and blah, blah, blah. Here it's the doesn't match. Like we can pass a bunch of words and ask which one doesn't match to this one. It's giving me an error now. I have no idea why, but it's possible because we have to do this on a list instead of using the split function, but that's fine. Okay, and now we check the model using the skipgram model. And if we can see here, we have 50 dimensions and they are different than the other ones. So we can see that the vectors are different and also the most similar words are also different. And that's because, like we talked before in the theory part, the skipgram use it's a different algorithm, learning algorithm. It will use, you will get as an input. So the only input I give them is the baseball. So I only give one word for them to give me in which context that word occurs. So we have to pay attention to that. And I just would like to show you these differences because that's a little bit what we're going to see in our homework. Also, when we start the applications, it seems very simple right now. And we usually use this part, like we are very lucky that we have the Word2Vec model already implemented and we can use everything from it. But usually later on, like we talked before, the word embedding technique is not enough. So we have to implement some other machine learning algorithms to make our vectors better, or to use our vectors for something, for some type of activity. So we're going to see this after we finish all the applications, so we can decide which one is better in each type of work that we have to do. Okay, this is what I have for Word2Vec. I'm glad that you guys are here, so thank you so much for watching this video. I see you next time. If you have any questions, please let me know. And also, use our extra information, our references, our the paper, read the paper, try to understand where they get this from. And also, this will be very important for us in the future. Okay, see you next time. Bye-bye.